discussing the construction of the synchronous machines. So the topics to be covered are synchronous machine construction, stator, under which we'll discuss the stator frame, core and winding, the rotor. There are two types of rotors basically, that is the salient pole and the non-salient pole type of rotors. In synchronous machine construction, the most important parts of a synchronous machine are stator, rotor and some miscellaneous, that is your fan, cooling system, then bearings. All these comes under the miscellaneous items. Then we'll come to the stator. The outer stationary part of the machine is called the stator. It contains the stator frame, stator core and winding. So you can look at the stator frame. These alternators are normally of a very high rating. That's the reason I have taken a pic of such a large stator frame. In alternator, the frame is used for holding the armature, stampings and windings in the position. Low speed, large diameter alternators have frames casted in sections. Ventilation is maintained with the help of holes cast in the frame itself. The provision of radial ventilating spaces in the stampings assist in cooling of the machine. Core frames are presently fabricated from mild steel plates welded together in such a way as to form a frame having a box type section. Now here you can see the frame of large turbo generator and large hydro generator. Normally you can see that the turbo generator are being axially placed while hydro generators will be vertically placed. Next comes the stator core. The top one is the core of the turbo generator while the bottom one is the core of the hydro generator. The armature core is supported by the stator frame and is built of laminations of a special magnetic iron or silicon steel alloy. It's laminated to minimize eddy current losses. The laminations are stamped out in complete rings for smaller machines or in segments for larger machines. The laminations are insulated from each other and have spaces between them for allowing the cooling air to pass through. The slots for housing the armature conductors lie along the inner periphery of the core and are stamped out at the same time where laminations can be formed. The next comes the stator core. The stator core contains different shapes of the armature slots as shown in the figure, that it can be wide open, semi-closed or totally closed type of the slots are available. The wide open type of slot has the advantage of permitting easy installation of form wound stator coils and their easy removal in case of repair. But the disadvantage is of distributing the air gap flux into bunches or tufts that produce ripples of the generated EMF. The semi-closed type slots are better in this respect but do not allow the use of form wound coils. The wholly closed type of slots or tunnels do not disturb the air gap flux, but they tend to increase the inductance of the windings. The armature conductors have to be threaded through, thereby increasing the initial labor and the cost of the winding, and they present a complicated problem of end connections, hence they are rarely being used. Next comes the armature winding. The slots are cut on the inner periphery of the stator core in which the three-phase or one-phase winding is placed. Enameled copper is normally being used as the winding material. Now here you can see a single coil which is being given a shape of such that it can be easily fit into the slots and the end connections can be properly being made. Now here you can see a number of coils which has been taped on the outer side because the remaining portion will be inside the stator while the end connections will be at the outer, which is subjected to many types of stress and therefore it is properly insulated. Here the windings are being placed in the stator where you can see large stator and you can see the thickness of the conductors which is being placed over here. We'll discuss the stator winding. You can see the turbo generator where the thick conductors are being used for the coils and it's a single conductor which is being placed in a single coil. This is the hydro generator. You can see the comparison of the current carrying capacity for the hydro and the turbo generators. Next comes the rotor. The rotating part of the machine is called the rotor. From construction point of view, there are two types of rotors named as salient pole rotor and non-salient pole type of rotor. The salient pole means there will be a projected poles and just by the naked eye you can know the number of poles on the salient pole type of a motor, and for the non-salient type of rotor you will have or complete circular circumference, and the conductors will be embedded inside it. So that is the non-salient pole type of structure. Now what are the basic features of the non-salient pole type rotor? There are no projected poles. The poles are formed by the current flowing through the rotor or the exciting winding. It is suited for high speed. A number of poles are required for the desired frequency. These machines have smaller diameter and larger length. Non-salient pole type rotors have the following parts. First, the rotor core. The rotor core is made up of silicon steel stampings. It is keyed to the shaft at the outer periphery slots in which exciting coils are being placed. It provides an easy path to the magnetic flux. While the rotor winding or the exciting winding, it is placed in the rotor slots and the current is passed through the winding in such a way that poles are formed according to the requirement of the given generator. Here you can visualize the rotor, and because it is a DC field and it is of the turbo generator, so only two poles are being formed. The special features of the non-salient pole are they are of a smaller diameter and of very long axial length, the robust construction and the noiseless operation, less windage or air resistance losses, better in dynamic balancing, and high operating speed is being attained by the non-salient pole type of rotors, and nearly sinusoidal flux distribution around the periphery is possible and therefore gives a better EMF waveform than that obtainable with the salient poles field structure. There is no need of provision of damper windings except in special cases to assist in synchronizing, because the solid field poles themselves act as the efficient dampers. Then comes the features of the salient pole type of the rotor. The poles are projected on the rotor. The cost of construction of the salient pole type rotor is low. Sufficient space to accommodate the field winding because it will be accommodated on the field pole. They cannot bear high mechanical stress at high speeds. It is suited for medium and low speed rotations, usually employed at hydroelectric and diesel power plants. Since the speed is quite low, so to obtain the required frequency, the machines have large number of poles. To accommodate a large number of poles, they will have the larger diameter and smaller length. For a speed of 200 rpm, alternators coupled with water turbines, that is in hydro generators, the diameter of the machine can be as large as 14 meters and the length is only 1 meter. You can see over here, you can visualize it that the diameter is very large while the actual length is very less. And normally hydro generators are vertically mounted. Special features of the salient pole. These are of larger diameter and shorter length. Usually 2/3 of the pole pitch is covered by the pole shoes. To reduce eddy current losses, the poles are laminated. The machine having such a structure are employed with the hydraulic turbines or with diesel engines, usually operated at low speeds from 100 to 375 rpm. There is an air gap between the stator and the rotor. So what's the significance of it? A very small air gap increases the stray load losses and synchronous reactance XD. A large air gap needs larger excitation currents. Therefore, a compromise has to be made between the gap length and the synchronous reactance. Generally, the ratio of air gap to the pole pitch is between 0.08 to 0.02. Now comes the damper windings. Normally on the salient pole machines, the damper windings are being provided. The reason being, dampers are useful in preventing the hunting, that is momentary speed fluctuations in generators, and are needed in synchronous motors to provide the starting torque. So when it is a synchronous motor with salient pole, it will give you the starting torque and therefore it can run at the synchronous speed. Most of the salient pole alternators have their pole shoes slotted for accommodating copper bar grids or dampers. The copper bars are short-circuited at both ends by heavy copper rings. Turbo generators usually do not have these damper windings, especially other than to assist in synchronizing, because the solid field poles themselves act as efficient dampers. Under normal running conditions, damper winding does not carry any current because rotor runs at synchronous speed. The damper winding also tends to maintain balanced three-phase voltage under unbalanced load conditions. Here is the small alternator. By visualizing, you can see that what it looks like, and here you can see the cut section of the alternator where you will find all the parts as the exciter, the shaft, air filters. It is for the diesel generator, therefore it will be air filters will be there. Then transformers to transform to the higher voltage, neutral point because it is star connected, line terminals for having the external connections, stator core, stator windings, end shield acts as a frame and the bearing shield. The D end bearing, that means the driving end bearing it is. Then you have got a fan, rotor windings, rotor poles, detachable feet, so that when as per requirement you can have it, and the diode bridge is used with the exciter for the rectification purpose. So today we have discussed about the synchronous machine construction, the requirement of the stator frame, core and winding, and what are the special features of the salient pole rotors and non-salient pole rotors and its specific application to the alternators. Thank you.